get some placement support after enrolling this course?
Sorry, can you be a little loud? I'm not able to hear you clearly.
After enrolling this course, can I get some placement support?
See, I'm not the right person to answer this. Maybe you can get in touch with Geeks for Geeks, somebody whom you would have contacted earlier. They will be the right people to guide you on this.
Okay, thank you.
Yeah. Okay. So let's start. I'll start the session. So as I said, this session is, first of all, good evening. This session for the next 1 hour, I'm going to talk about stats, right? Now, stats is a huge, vast subject, and it's difficult to cover. Even if I have to just talk about statistic, which is relevant for data science, even if I have to cover this limited portion only, 1 hour will not do justice to stats. So what I am going to do is I'm going to talk about certain basic concepts. I will give you an introduction and maybe a first level detailing for each of these concepts. Your job is to then go back and deep dive into each of these concepts to understand it better. So what I will do is I will try to make it as simple as interesting and give you, maybe I'll take you from level 0 to level 1. But then once the session is over, maybe you can go back, read some books or do some search on Google and then take your understanding from maybe level 1 to level 2. And then with more practice and more reading, these concepts will slowly get better with time. Yeah. Everyone is with me so far?
Yes, ma'am.
Okay.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, so let's get started. So basically, I have structured the presentation in this format. Initially, I will talk about what actually statistic is and why are we even studying stats. I'm not sure what is the background of most of the students here, but given that you are interested in data science, I'm assuming most of you are engineers. Now, as engineers, we don't do stats, right? So why at this point we are looking at as stats as a subject? I'll give you a little bit understanding of that. Then we deep dive into different types of statistics. So there is descriptive stats, there is inferential stats. We look at what is the difference between these two and how do these two statistics help us when we are doing a real data science project. Within descriptive stats, we will look at measures of central tendency and variation. And within inferential stats or inferential analytics, we will look at probability distributions, hypothesis testing, central limit theorem, correlation, and covariance. Now, these terms, don't get scared. It might look very heavy, very big, and very new because most of you, as I said, if you're engineers, you have not looked at these concepts earlier. It is okay. This is just an introductory class, basically just giving you a little flavor. This is not meant, it is not like after this 1 hour, you will be able to, you will be able to understand stats completely. That's not going to happen. This class is only to give you a little flavor so that then you can take up these concepts ahead and study yourself. And of course, once you join a proper class, there will be more training provided. So this is an introductory class. I will try to make it as simple and as interesting as possible. Okay. So let's look at why stats, or why for that matter, data has become very important today. So, when I was of your age, maybe about 20 years back, most of the decisions that the companies like any company for that matter you can take, right? If say for example HUL or Reliance or Infosys, any company for that matter, big or small or medium, the decisions that they would take would be based more on intuition. Why? Because the tools and the technologies that you require to capture data, to analyze data, and to gain insights from the data was not available then. So most of the decisions that were done were mostly subjective. It came from experience of senior people who had some intuition, some understanding about how the business is performing, but they did not have an end-to-end picture. But fast forward 20 years, and if I look at the time today, we have all the tools and all the technologies that are helping the companies not only capture the data, but also analyze this data and gain insights. And then today, data science and machine learning as a science has also evolved. So today, most of the, in fact, all the decisions, all the planning that companies make, it actually happens based on the data and not on intuition. And that is why today, data science, data analytics, streams like this, which never existed earlier, right? Statistic as a science and statistician as a professional would used to exist. But today you see a lot of data engineers, data science, data analytics, data analyst professionals also today, different roles you see, right? So the reason why you see this is because today capturing data, storing data, analyzing data has become very simple, has become very easy, and therefore most of the companies are now going through this route. And therefore it has become very important that we look at data, we try to understand it, we make certain inferences from it, we analyze the data, and then based on our understanding, we go ahead and make certain decisions, right? So this is about why the database decision making has become more of a norm than an exception. Now, how do we go ahead and make decisions based on data? So that whole science is known as stats. So if I just have to define what is statistic, it is a science that deals with the collection of data, analysis, interpretation, and presentation of empirical data. Empirical data, or you can just say data. Empirical is basically, you can say data that you collect from experiments, but basically stats is the entire science from collecting data to analyzing, interpreting, and then you present it to your senior stakeholders who then use this data to make certain decisions. All of you with me so far?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Ma'am.
Great.
Yes, ma'am.
Okay. Now
Yes, ma'am.
let's go. Okay. Now this is a
Yes, ma'am.
question which, great, thanks. This is a question which I would want to ask you towards the end of this session. Maybe it is too premature to ask this, but I would want to know after this session, why do you think as a data scientist or as a data analyst or an aspiring data scientist, data analyst, why do we need to learn stats? So this is a question that I will ask all of you at the end of the session. For now, let's go ahead. Now, as I said, stats, there are two key branches which are relevant for the field of data science. First is descriptive statistics. So basically, this is the branch of stats that deals with the past data, something that has already happened, right? So say, for example, I am a company and I've been um, I'm an organization which is almost 10 years old. So now for this 10 years, I already have data in terms of what are my sales, what are my cost, what is the number of employees that I have, right? What are the profits that I am making, so on and so forth. So this data is already existing. It is past data, and descriptive stats, what it does is that it uses this data to make certain insights, right? So when I talk about, again, let me give you another example. So say, for example, I am Geek4Geeks, and there are a lot of students. I have the data of all the students that have been learning data science for the last 5 years. So I have their names, the age, the what are their educational qualifications, so on and so forth. Okay, I'm not sure how is this happening. I can see. Do you also see this, or is it only I who can see certain marks on
Yeah,
the?
there is a cross
Yes,
mark.
ma'am.
Yeah, whoever has done it, can you please remove it? Yeah, thank you so much. Thank you. Yeah.
Hi.
Say, for example, any questions? Okay, let's go ahead. So say, for example, Geek4Geeks, it has been in existence for the last 5 years. It has data for all the students that have taken various courses. So now Geek4Geeks will have data for the student names, where they are based out of, what are their educational qualifications, what is the percentage of marks that they have got in standard 12, standard 10, what kind of jobs did they get, do they have any professional experience before joining Geek4Geeks. So these are various data points that Geek4Geeks will capture. Now, once it has captured this data, it will go ahead and try to analyze what is the mean age of students who are coming for learning data science, right? Or it would look at what is the qualification of students who are coming to learn data science. So basically, when you start looking into analyzing this data in terms, and you summarize it, right, that is known as descriptive statistics. It is basically talking about it describes the data. And how does it describes the data? It uses certain statistical measures like central tendency, where we will look at these measures in the next slides, but it will use measures of central tendency, measures of variation, and come up with certain insights. So this part is descriptive stats. Basically, it looks at the past data and captures what happened. The second branch of stats is inferential statistics. Now here what you're doing is you are, this is basically or mostly used when you are conducting a certain experiment. Now when you do a certain experiment, of course you would like the sample of the experiment to be as huge as possible. For example, there is a company, let's try to understand this with an example. Let's say there is, I'm launching, I have a company and I want to launch a certain soft drink in say tier 1 cities, right? I'm going to launch that. Now I want to know how much is the market demand for that product. So what will I do? I will look at certain set of tier 1 or tier 2 cities, and I will look at whether the competitors already have launched. Then I would look at how much is the sales of those companies coming from um, these particular cities, right? What is their market share? How much is the revenue that they are making? So basically what I have done, I have collected a certain sample, and now I am looking at the revenues of my competitors in each of these cities. So this has become a sample, and using this sample, now I'm going to conclude something, or I'm going to make a statement saying whether this product is successful product or it is not a successful product. So when you, instead of a population, you look at a small sample and then you try to generalize about that sample, that science is known as inferential statistics. And I will give you more examples when we go further. This inferential statistics requires a little bit more understanding and practice as compared to descriptive, because descriptive more or less is your maybe fifth or sixth standard maths. Inferential is actually more about stats and less about maths, where you collect a sample, do an experiment on that sample, and then you try to generalize that because my samples is saying me this, possibly the population is also saying this. So you kind of generalize about a larger group by analyzing a smaller data set. And there's a lot of techniques that you use in inferential statistics, like hypothesis testing. You look at sampling, you look at analysis of variance, which is another hypothesis test. So this is another part of stats, which is inferential. It builds and tests hypothesis from the data. Any questions so far? Any doubts? Are you clear with what descriptive stats does and what inferential stats does?
Madam, I have one
Yes,
question.
ma'am.
Yeah.
So, is inferential statistics responsible for predictive analysis for
Yes.
AIs or any models?
Yes. Yes.
Okay, thank
Yes. Actually, both of them are. So what happens is when you are doing a real data science project, right, you will be given a lot of data. There will be one dependent variable and there will be 100, 200, maybe more than that independent variables. So what you will have to do is you will have to then analyze each column. And when I say column means each variable. So you would look at how what is the mean value of the variable, right? How much is the variation in that variable? Then you will look at how does the variation in that variable associated with the variation in the dependent variable. So this is where the descriptive statistics or descriptive analytics will play a role. When it comes to inferential stats, based on the data, you will create certain hypotheses, right? Now you will have to test that hypothesis. What is hypothesis? Basically, your data is saying that, say, X is related to Y. Right now, you will have to do certain tests to check whether your claim is correct or not. So you will do certain hypothesis testing there. For example, say you're looking at a salary data. Now you have salaries of men and salaries of women. What you see is that the average salary of men is more than the average salary of women. Now this is what you are seeing from the data. When you plot the data, you can see the average salary of men is, say, 10 lakhs. The average salary of women is 6 lakhs. Now here, once you have made that hypothesis, you will have to do some testing, which is known as hypothesis testing, where you will do certain kind of test to conclude whether your claim is correct or not. That is where inferential statistics will play a role. So yes, as you are rightly said, it is both descriptive and inferential statistics that will come into picture when you start working on real life use cases.
Thank you.
Ma'am, I have a question.
Mm-hmm.
So we learned statistics and math for the first 2 years of an engineering course.
Mm-hmm.
Do we need more of statistics if you want to go into data science?
See, statistics. So I'm the topics that have been given to you, right? It is because what I was told is that there have been certain documents that they have shared with you, which cover topics like certain distribution, hypothesis testing, correlation, ANOVA. All these topics are necessary, especially when you are dealing with traditional data science. I'm not talking about Gen AI and all, but when you're talking about traditional data science, where you're looking at algorithms like linear regression, for example, right? Linear regression is actually a statistical technique. It's not a machine learning technique. So there, when you look at individual p values, you look at if you're doing you would be looking at correlation, you would be conducting certain hypotheses, you would look at type 1, type 2 error. So all of that becomes important. So yes, when you are starting out, a good amount of strong statistical knowledge is required. But again, if you understand the basic concepts and maybe to some extent a little in little detail about certain specific topics, that is sufficient. You do not need to be a master's in stats to actually be good in data science.
Thank you so much, ma'am.
Okay, any more questions? Okay, I'll go to the next one. So yeah, so now let's look at descriptive stats. As you can see, there are two tables here, and because this is very easy, I'll take you through this quickly. Unless you have questions, you can stop me. So this first table is where you have your student serial numbers, and then you have the weights of the students. So this is basically a numerical column. And in the second table, you have your customer serial numbers, and then you have their genders, right? So now if I have to use descriptive stats, or if I have to use descriptive analytics here, what is the first thing I will do? I'll calculate the mean of this column, right? So mean is basically just your average. This is very simple. Just calculate the average of the weights of the students in the class. The second most important statistics after mean is the median weight. So what you do in median is basically you sort this column and you arrange it in ascending order. And then the number that comes in between, which basically divides your data into two equal parts, is your median value. Now here, if say for example your number of observations are odd, then it is simple to find out the middle value. If your number of observations are even, then you will have to take the two values in between and take an average of that. That will be your median value for the weight, right? And then you have mode, which is basically the most frequently occurring value in the data. Now, this is a numerical column. So here, even if I say that mode is, I don't know, I've just randomly put numbers here, but say, yeah, I can say mode is 58. It is okay. It doesn't really give me any insight, right? It's not telling me anything specific. But here, if I look at this column where my variable is categorical, it is not numeric. If here the mode is female. So say for example, if I had a shop and I was just noting the gender of customers who are coming to me, this is of importance to me, right? The mode is more important when you're looking at categorical variables. The mean and medium becomes more important when you are looking at numerical variables. So I have just done this exercise here just to show you this. So basically, this is uh, your data. This is basically just looking at, these are all Excel formulas where you can calculate the mean and the median. Now, let's go one step ahead. This I'm sure all of you can do, right? And I've already answered the third question. For what kind of data is mode more relevant? Mode is more relevant for categorical data. So when you talk about measures of central tendency, mean is the most important statistic. In fact, in hypothesis testing also, most of the testing happens around on the mean. The mean of group A is different from mean of group B, or mean of group A is equal to mean of group B, so on and so forth. So while it is a very simple statistic to understand, its use is very high, right? Median is something that we use when you are drawing certain charts. When you are, say for example, when you visualize the data, when you draw certain charts, one of the charts that you will draw for numerical columns is the box plot. I don't have it ready here, but you can of course Google, and you would see that when you draw a box plot, there will be a rectangular like structure which will show you where the mean is and where the median is, right? So it basically will tell you what is the median value of salary across genders, or maybe what is the median value of sales across cities, across products, so on and so forth. So median is also an important statistic for numerical columns. When it comes to categorical columns, mode becomes very important. For example, you have a data set where you have been given cities, right? Cities is one of the column, and there are 200 cities given to you, right? In that data set, which has say about 500 observations, there are 200 different values of cities. So do you think you would be using all the 200 values? What do you think?
No, ma'am.
I can
Right?
take the sample of the values.
Yeah. So what you would do is that you will not take a sample, because you anyways have only
Range, ma'am.
500. Sorry.
We can use the range.
Yeah. So okay, so let me just explain from where I am coming from. So when I am, and maybe this is a little mature because I'm directly jumping into a data science problem, but I'm just trying to link this to how the mode will matter, right? So say for example, you have a data set where you have 500 observations, and there in 500 observations, you have been given 200 cities, each occurring at a different frequency, right? So what you would do is you would basically take only the top 10 as different cities, and the remaining you will just club it into others. Because when you are creating a model, you do not really need, you cannot use a categorical column as it is. You will have to do a certain kind of encoding on that variable. So when you are encoding a variable, what will happen? There will be a separate column for Delhi. There will be a separate column for Mumbai. There will be a separate column for all the 200 cities. Now, this is going to make your data very huge, right? Which is not recommended. So what you would do is maybe you will just take the top 10 cities which are occurring at the highest frequency, and for all the other cities where the frequency is very less, you will just club it and create another column which is others. So this frequency is where mode comes into picture. Over here, female gender, it is 3 out of 5. The frequency is high. Now, of course, this is simple because you can only have two genders. But for example, if I had a city column here and I had a lot of cities with few cities coming only once and few cities getting repeated a lot of times, then what would you do? You would keep the cities that are being repeated frequently, and all the cities which are only coming once or maybe twice, you would just club it and put it as others, so that you will only have, say, 5 columns. You would have Delhi, Mumbai, Chennai, Calcutta, Bangalore, and then others. Right? So that is where mode plays an important role, or that frequency plays an important role for categorical columns. If this is not making sense right now, it is absolutely okay. You just have to remember that mode is the most frequently occurring value, and it is more important for columns which are categorical. Clear?
Okay.
Okay. I'll go to the next part of descriptive stats. This is basically your measures of variation. So we looked at the central tendency, which is basically your mean, median, mode. Now for every data that you have, while you have calculated the average of every column, you also need to look at what is the overall variation in the data or in that particular variable. So I can say that the average weight of student is whatever, say 50 or 53. But how much is the weights of other students varying from the mean average, right? That is calculated by, or that is given by the variance. So basically it measures the variability in the data from the mean value. So if you see here, let me use the laser. So this basically is what? This is my observation. So for student 1, xi is 50 and say the mean value is 58, say for example. So now I'm going to do what? I'm going to do 50 minus 58 and then I'm going to square it. Why am I squaring it? Because if I don't square it, what would happen? Can anybody guess? I'm going to
Native
calculate
values.
this. Sorry?
Native values will be present.
Yeah, and these negative and positive values may cancel out each other. So this will not give me a complete picture of variation. That is the reason why I am squaring this, right? So I square the difference and then I divide it by the number of observations in the data. This gives me the variance in the data set, right? So when I say the variance of the data is X units, basically I'm saying the variability in the data set from the mean value is X. Let me show this to you. I had done this to just give you a better idea. So now if you look here, is the Excel visible, guys?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Great. So now you
Yes,
have a
ma'am.
list of 18 students here and you have the values of the weights, right? 50, 58, 53. So you can calculate the mean. Mean is basically just taking the average, you get 52.7. Now what I will do is for each of these observations, I will calculate the difference. So it is the difference between 50 and 52.7. So this is X minus the average. And then I square it. So when I square this, all my values that I'm getting is positive. Here, it is highly possible that my positive and negative values can cancel each other if I don't square it. So what I do is I square all the values and I calculate the total sum. The sum is 1610. So now what is the variance? The variance is the sum of the difference squared divided by the number of observations. So this is the sum, the squared sum, and this is the number of observations, which is 89.4, sorry, which is the number of observations are 80. So when I do this calculation, I get variance as 89.4. So this is the variance in my data. But the problem with this is, and if you would have noticed, what is the unit I'm getting here? It is the weight squared. Why? Because I have done square here. So the weight, now that the unit that I'm getting of the variance is different from the unit over here. Weight is in kgs. This I will get in kg squared. Now, can I make any sense out of it? I maybe make some sense out of it, but would that be intuitive? Would I be
No,
really
ma'am.
be able to,
No,
yeah,
ma'am.
right? Right. So then what do? We actually take the square
Square
of
root.
this variance, right?
Square
So
root.
when we take the square of the variance, now the unit is back. I will get it in kgs. So I'm saying the standard deviation is 9.5. So when the standard deviation is actually the square root of the variance, it does exactly what variance does. It gives you the dispersion of data from the mean, but the advantage of using standard deviation is that the unit of the standard deviation is the same as the unit of the variable that you are considering. So it becomes very easy to understand that, okay, the standard deviation here is basically 9.5 kgs. So the dispersion of data from the mean, which is about 52.7, the standard deviation of this data is 9.5. So the data is varying from the mean by 9.5 units on an average. Is this clear? Is this concept clear? This has to be very clear because you will be
Yes.
using standard deviation extensively.
Yes,
Ma'am,
it's
I have a
clear.
doubt.
Yeah.
Ma'am, here the variance is calculated for population mean, right? But
Hmm.
when we calculate the same for sample mean, we divide it by n minus one. Why
Right,
n minus one?
right. There's a concept called Bessel's correction, which is basically it talks about um, I'm not able to recall. It's basically taking into consideration the number of in the degrees of independence, right? You will have to look onto it. I don't remember exactly why they do it, but it is called Bessel's correction, and they take into account the degrees of freedom, sorry, not independence. The degrees of freedom reduces when you look at a sample instead of a population, and that is why you divide it by n minus 1 and not n.
Okay, ma'am.
Any other questions?
No, ma'am.
Okay, so yeah, you can actually look at why it is n minus 1. As I said, it is more about using degrees of freedom. Uh, but just look at it because I don't remember on the top of my mind why it is n minus 1, but I do remember that it is to adjust the degrees of freedom when you're using a sample. Yeah.
Yes, ma'am.
Okay. Fine. So this we already did. Why do we need standard deviation when we have variance? One more thing I wanted to cover. Not sure if you are covering in your documents that have been shared by Geek4Geeks, but interquartile range is also a very important concept when you talk about variation in the data, right? So interquartile range, or commonly known as IQR, it is a difference between the third quartile and the first quartile of the data. Now, when you're talking about quartiles, the first thing that you need to do is you need to sort this in ascending order. So what am I saying when I say first quartile? First quartile is basically the number of observations in the 25% of my data is less than a particular value. That value is the first quartile. So quartile, you understand, right? It's 25, 50, 75%, the 1/4 of the data. So when I say the first quartile, I'm basically looking at 25% of the observation, and I'm saying the 25% of my observations is less than this particular value. This is the first quartile. Similarly, the second quartile is basically your median, which is 50. And then the third quartile is the 75% of the data. So I'm saying 75% of the data is less than a certain value. That is the third quartile of the data. So what IQR does it gives you the difference between the third quartile and the first quartile. Now, why do you really, in fact, even need IQR? Because IQR will basically tell you what is the variability in the middle 50% of the data, right? And the best use of IQR is to understand how many outliers do you have in your data, which are these outliers, what are their values. So outlier is basically, not sure if you already know this, but outlier basically you would have seen, say for example here, you see most of the numbers are in the range of 40 to 50, but there are certain outliers here. Say for example, 75. This is way, way beyond the mean value of 52.7, right? It is very far from 52.7. Similarly, you see there's an underweight student with the weight 30. So this is also very far from the mean value. Now, it is possible to have certain outliers. It is natural to have certain outliers, but we need to distinguish whether these outliers are because of some wrong calculation or wrong surveying that you have done, or it is just the nature of the data that these outliers are present. And then based on whether it is case 1 or case 2, you decide whether you want to continue these or you want to retain these outliers in your data, or you would want to remove these outliers. But the concept of IQR basically is is identifying these outliers, and you identify it by using these formulas. So Q1, which is your first quartile, minus 1.5 into IQR will give you the outliers which are in the lower range, and Q3 plus 1.5 into IQR will give you outliers in the range which are above 75. So let me show you something just to make this little bit more intuitive. Have you heard or seen a box plot earlier?
Yes, ma'am.
Yes,
Yeah?
ma'am.
Okay, great. So now if you see here, these values that you see, so these values that you see are basically the outliers. And this is 1.5 lower. So this is quarter 1 minus 1.5 IQR. This is quarter 3 plus 1.5 IQR. So the values that you see beyond these becomes your outliers. And therefore, it is in this context that IQR becomes important. If you see this is basically the best, maybe to show you what IQR means. This is your 50% of the data. This is your lower quartile, 25%. This is 50%. 50% is the median. This is the 75%. So when I say my upper quartile is say 75, which means that 75% of the observations are less than a particular figure. When I say the lower quartile or lower quartile says 34, which means that 25% of the observations are less than that particular value. And all the values which lie over here or over here is given by quartile 1 minus 1.5 IQR and quartile 3 plus 1.5 IQR. And therefore, in this context, IQR becomes an important concept to understand. Any questions here?
Yes, ma'am.
Yeah, tell me.
Ma'am, can you please explain how can we find first quartile and third quartile again?
Okay, so let's take this. Okay, so now what I have done is I have arranged this data in the ascending order, and I have 18 observations, right? So 0.25 into 18 observations are 4.5. So what I'm saying is 25% of the data should be less than a particular figure. So if I look at the first 4, so 4.5 is the first, 25% of 18 is 4.5. So I will look at the first 4 to 5 observations. The first quartile should be somewhere between 47 and 48. If you go here, right, and there's a formula here, you can see it is quartiles C3 to C20. This is my data range, and I'm saying this is the first quartile. So it is giving me 48.3. If you see here, it has considered these values and it has calculated the quartile 1, which is 48.3. So I can say 25% of my observations is less than 48.3. Can I say this? This is 47, 45, 40, and 30. 25% observation means how many? 4, 4.5, or you can consider 4. So 4 of the 18 observations are less than 48.3. This is my first quartile. Is this clear?
Yes, ma'am. Thank you so much.
Right. Similarly, I will calculate the third quartile. Third quartile will be what? 0.75 into 18, which is 13.5. So let's look at this. How many are this? This is 13. So I can say 75% of the observations, which is basically 13 out of the 18 observations, are less than 57 around. What do we get? Yes. So we say we get the third quartile as 57.8. Is this clear? So this is
Yes,
how,
ma'am, please.
yeah. So again, you have this formula here. The data range will stay the same. You say third quartile is 3. So this is your 57.8. Then the interquartile range is basically third quartile minus first quartile. So I just do a subtraction here. I get 9.5. Right? In fact, if I do quartile, and then I select this data and I do 2, see, this is giving me 52, which is the same as median. Why? Because the second quartile is again your 50% of the data. So 50% of the data lies or is less than 52. 50% of the data is more than 52, which is basically your median. So this is how you can calculate the first quartile, third quartile, and the second quartile, which is always your median. You can either calculate using this or you can calculate using the median formula. Clear?
Yes, ma'am.
Yes, ma'am. I have doubt,
Ma'am,
ma'am.
Yeah.
Okay.
How is IQR used to detect outliers?
Okay. So what happens is, if you see here, this is your box plot. And I'm referring to this diagram because only then you will be able to understand. When I say this is my Q1, this is the Q1, this is the minimum value. This is the minimum value, this is Q1, this is median, this is the Q3, and this is max. Now, when I'm saying it is Q1 minus 1.5 IQR, basically I'm talking about values which will lie in this range. Then when I say Q3 plus 1.5 into IQR, I'm talking about values which will lie beyond the maximum value. So values which are in this range and values which are in this range, right? You will only have few values. Sometimes you can even have many values, but mostly you would see they are outliers. They will be between less to medium number of outliers. They will be lying in this range, away from the median, away from your quarter one, away from the quartile Q3 values. So those are your outliers. Let me see if I can find, see over here, you can see this is an outlier. Maybe when you start plotting, or when you start looking at drawing, let's do this. Yeah, do you see this chart? These are your outliers. This area that you have is given by Q1 minus 1.5 into IQR. This area is Q3 plus 1.5 into IQR. Any values that lie over here or here are your outliers. And that is why IQR becomes important, because it helps you to identify these outliers. The whole concept of box plot is actually showing what is the interquartile range, what is your 75th quartile, what is your 25th quartile, and then are there values which are less than 25th quartiles or values more than the 75th quartile. Does it
Thank
make
you, ma'am.
sense now? Is it better? Do you understand it?
Yes, ma'am.
Yeah. Okay. So fine. We have covered descriptive. Any questions on these two? They look
No, ma'am.
simple, but you will be using it extensively. Okay, great. So now let's go to another concept, which is probability. How many of you feel comfortable with the concept of probability? It's a tricky concept. It again comes with, yeah, right. It comes with practice. It is initially when you start learning about what is a joint probability, what are independent events, what are mutually exclusive events. All of it sounds very confusing. I'll try to simplify it as much as I can. So first, let's understand probability in a very simple term, right? Now, say for example, 100 students joined GeeksforGeeks in the month of July, right? Or maybe 100 students joined GeeksforGeeks last year in the month of July, out of which 30 students could get a job, right? So what is the probability of getting a job? It would be 30 by 100, right? Probability of getting a job is an event. Getting a job is an event, right? So the number of observations in favor of the event, it is 30, divided by the total number of observations, which are 100. So there were 100 students who joined, 30 got a job. So the probability of getting a job is 30 by 100, right? If you look at this example, a company has 1,000 employees and every year 200 employees leave the job. Then what is the probability of attrition? Attrition means people leaving the company, right? What is the probability of attrition of an employee per annum? So what is this? The probability of attrition is the number of
50%.
observations in favor, which is 200, divided by the total number of observations, which are 1,000. So it is 20%. This is clear?
Yes, ma'am.
Yeah. Now let's look at certain rules of probability. These are very simple. You can let me know if you know the answers to this. This is basically common sense, but it is also,
200 by 200.
sorry. Okay, so let's go to the first axiom. Axiom means basically fundamental concepts of probability, or you can say fundamental rules of probability, right? The first is the probability of an event. What is the range of probability? What can be the maximum probability? What can be the minimum probability?
0 to
Anyone?
1.
1 or
0 to
0.
1.
0 to 1, right? Very good. So yeah, so this is the first axiom. The probability of an event E lies between 0 and 1. The probability of the universal set is, first of all, what is, yeah, tell me.
1, 1.
1, right? So for people who are still thinking, universal is basically, I put in all the events here. For this, for example, say over here, a company has 100 employees, right? And 200 employees leave the job. So leaving the job is one event. So either you are leaving the job or you are continuing in the job, right? So this is the total universe, because these are the only two possible outcomes. So the probability of person leaving the job is 20%. So, and the probability of people continuing in the job is therefore 80%, because 800 employees would continue in the job. Now, when you add 20 and 80, what do you get? You get 1. Right? Similarly, you could also have a universal set which has more than 2 outcomes. But when you add up the individual probabilities, it will always add up to 1. Therefore, we say the probability of the universal set is 1. Yeah? Clear with this?
Yes, ma'am.
Okay. Now let's go to the other one. This is very simple. For an event A, the probability of the complementary event is
1 minus A.
great. Okay, let's go to
1
the other
minus
one. Yeah. The probability of an empty or an impossible event is
0.
0.
0.
Yes,
0.
right. The probability that either event A occurs or B occurs or both occur is, this is a little,
Probability of
this
A
is,
union B.
yeah,
1.
it is P,
Okay.
A union B. It is the probability of event A plus the probability of event B minus the probability of A intersection B, right?
Yeah.
We will cover this in the next few slides also, where we will start looking at different types of probability. But this is basically the concept that the probability that either event A occurs or B occurs or both of them occur is given by probability of A plus probability of B minus probability of A and B. The last one, if A and B are mutually exclusive events, the probability of A intersection B is,
Probability of A or B.
no, these are mutually exclusive. Means they
Probability
can,
of A into probability of B.
Okay. Can someone tell me what are mutually exclusive events? What do you mean by mutually exclusive events?
Common between
Cannot
both
both
of
happen
A
at
and
one
B.
time.
Event A is not dependent
The
on
common
event
element between A and B.
B. Event A and event B are independent.
And the both events are not affected by each other's presence.
Yeah.
When two events does not occur at the same time.
Exactly. They cannot happen at the same time. So what is the probability that it is happening at the same time? It is zero because they
Zero.
cannot happen at the same time, right? What is PA intersection B? It is P of A and B. So if A and B cannot happen together, then the probability of A and B is zero. Right?
Yes, ma'am.
If say for example, and when you are learning probability, the most common example that you would come across is either rolling a dice or taking rolling a dice or a coin, flipping a coin, right? Or drawing a certain card from the pack of cards. Now just take for an example, you are rolling a dice. Can you get 6 and 4 at the same time?
No, ma'am.
No, ma'am.
You
No.
can only get one. You can either get 4 or you can get 6. So this event of getting 4 and an event of getting 6, when you are rolling the dice only one time, is a mutually exclusive event. It can never happen. So the probability of this is 0. Clear?
Yes, ma'am.
Yeah. Okay. Let's go ahead. Okay. Now we will look at certain terms which again you will find a lot when you start looking at probability. Again, once you start practicing this, you will start getting more comfortable. Let's first start with the simplest of it, which is marginal probability. So this is the simplest because it's basically just looking at a probability of an event in isolation. I go to a shop and I buy a bread, right? So the probability of purchasing biscuits or probability of purchasing bread or probability of purchasing, say, chocolates, this is something which is happening in isolation. It has nothing to do with any events that have happened earlier, right? So this is the unconditional probability. It does not depend on anything. It does not get influenced by anything, any event that has occurred before it or it's occurring alongside it, right? So marginal probability is simply a probability of an event occurring without considering any other events. For example, say you are working in a bank and you are in the say for example, you are in the loan default team. You're basically looking at all the people who have defaulted. So the probability that a customer will default is the marginal probability. But now you have the data of all the customers who have made a default. You are analyzing this data and now you want to calculate the probability. What is the probability that a person is a female or a person is married and has already committed a default? What is the probability of that? That becomes a conditional probability. So here the events, you are calculating the event, the probability of an event in isolation. Here you are looking at the probability of an event given another event has also occurred. So that is a conditional probability where given an event A has happened, you are looking at a probability of event B. A is the customer has defaulted. B is the customer is a female, right? So that in such cases you calculate the conditional probability, which is the probability of an event occurring given another event has also happened. The simplest example is I go to a provision store and I buy bread, right? That is a marginal probability. But once I have purchased bread, what is the probability of getting butter? That becomes a conditional probability, right? Because when I'm just purchasing bread, it is okay. It is not linked to any events. But mostly when you buy bread, you will of course also go and buy butter, right? So conditional probability of purchasing, the probability that a customer will add butter to his shopping basket given he has already added bread is a conditional probability. It is given by probability of A given B has happened equal to probability of A and B divided by probability of B, where this, the denominator, of course, has to be greater than 0. So forget about the formulas. From a concept perspective, is this clear?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, now let's look at joint probability, right? How is it different from marginal and conditional? So joint probability represents the probability of two or more events occurring together. When you are drawing a card, right, from a pack of cards, the probability that it is red and it is a king, right? It is two events that are occurring together. The sequence of the events does not matter. So it is not like the probability of A given B has happened or probability of B given A has already happened. The sequence does not matter, right? So that is where it is different from conditional probability, but it is different from marginal probability because here there are two or more events occurring together. When if it is only two events, it is given by P of A intersection B. Now, again, within joint probability, there can be independent events and there can be dependent events. For independent events, the joint probability is probability of A into probability of B. For example, I go and purchase bread and my friend also goes and purchase bread, right? These are independent events. It has nothing, my purchasing bread has nothing to do with my friend purchasing bread and vice versa. So these are independent events. For that, the joint probability is the product of the individual probabilities. Yeah, is this clear?
Yes, ma'am.
Yes, ma'am.
Right?
Yes.
But this will be different for dependent events. Why? For example, again, using the cards example, the probability of drawing, say, a king, right? When you have 52 cards, will be different. But then once you draw a card and then you do not replace it, then the probability of again picking a card and having it as a king will be different, right? Why? Because it is a dependent event. Say for example, you pick a card first, you get a king, right? So now you only have one red king present. So the probability of drawing a king again has reduced. So this is a dependency because it is dependent on the first event. And because there is a dependency on the first event, this becomes a conditional probability. It is given as P of A and B, which is P of A condition to B has happened into the probability of B. Again, don't get confused in the formulas. Just understand the joint probability. What is joint probability in independent events? What is joint probability in dependent events? When you are talking about independent events, you are basically just looking at individual or marginal probabilities because it has no bearing on what others are doing or on any other events. They are independent. They don't have any kind of dependence. But for dependent events, the joint probability actually becomes a conditional probability.
Okay, ma'am.
Yeah, is it clear to everyone?
Yes, ma'am.
Okay,
Yes, ma'am.
great.
Clear.
Yeah, we are already at 6, so let me know, do you want to continue or do you want to stop here? Is it because has it become too much for you to take it? We can stop here. Otherwise, we can proceed ahead.
Continue.
Ma'am, please continue.
Okay, great. So for people who want to drop, yeah, please. I can't see people who raise hands. Yeah, let Naveen, do you have a question?
Yeah, good evening, ma'am.
Yeah, hi.
Yeah, ma'am, my question is there any place where we can practice such statistics based questions with their explained answers so that we can increase our understanding onto statistics that is required for that? Or is it simply we simply start with the projects so that we understand statistics, how is it
No,
implemented?
I wouldn't recommend that you start with projects. I would recommend you start with examples. And first of all, it's good to you can basically look on Google. You would see some documents where there would be certain examples given. And I think Geek4Geeks would also be kind of having some documents where they are covering these concepts in more detail with the formulas and examples. So first thing is reach out to them if you have already enrolled in some course. And if you haven't, then you can look at YouTube, you can look at Google. There are a lot of PDF books also available. You can search that and find a good number of examples that covers these concepts, and that will make it more clear to you.
Okay, ma'am. Understood. Thank you,
Yeah.
ma'am.
Ma'am, good evening.
Yeah. Hi.
Yeah, hi, ma'am. What are the days for the classes?
Sorry.
What are the days for the classes?
I am not able to hear you.
Like, what are the fixed days for the classes?
Oh, okay, okay. Again, I am not the best person. I have just been asked to take a session on stats. So all these admin questions, I think you should reach out to the admin guys in Geek4Geeks. They will be able to guide you better.
Okay, okay.
Okay. Maybe let's
And
take
like,
another. Yeah,
is
yeah,
it
yeah.
required to have a good understanding of stats and probability for this machine learning?
See, what happens is, say for example, you are doing logistic regression. Do you know what logistic regression is?
Not yet, not yet.
Okay, so logistic regression, you are basically your dependent variable is a categorical variable. It's not a numeric variable, right? So you're not using linear regression, you're using logistic regression. Now, when you predict, say for example, the most, again, very specific use cases, say a customer will default or not, right? Uh, Either he will default or he will not default. But when the model is not going to give you 0 and 1, while it will give you 0 and 1, but what it is doing at the back end, it is calculating the probability. So if you don't understand the concept of probabilities here, or at least basic concept, basic fundamentals of probability, then when you start doing classification algorithms, right, for example, random forest, decision trees, logistic regression, which gives you output in the form of probabilities, then you will not be able to kind of connect the dots or understand what the output is. While you have all the Python codes which will exactly give you how many zeros and how many ones in your test data set, basically what happens at the back end is also something that you should understand. The model gives you a certain probability. It will give you say 0.6 or 0.3. Now, if your benchmark probability is 0.5, anything more than 0.5 will be classified as 1, anything less than 0.5 will be classified as 0. However, if your benchmark probability is 0.8, anything less than 0.8 will be classified as 0, anything more than 0.8 will be classified as 1. So there the concept of probability comes into picture, and therefore little understanding of probability is required, if not detailed. Is being honest with you, you don't really have to kind of deep dive into lot into probability, but basic concepts to pata hona chahiye.
Yeah, enough. We are enough with the basic, like reading the things. Not much is required about these probability and stats.
So whatever I have covered here, at least just try to do that much. Try to understand the concept, look at various examples, see if you can understand what are independent events, what are dependent events. Not go and do 50 questions for each probability, but just do about 7 to 10 so that the concept becomes clear. That much should suffice.
Okay, okay, okay. Thank you, thank you.
Yeah. Any other questions? I saw a few hands that were raised. Okay, no questions, then I'll move forward.
Good evening, ma'am. I have one question.
Yeah, tell me.
Ma'am, currently I'm a final year student and currently my drives are aligned continuously days. So, ma'am, basically I have just a question. So, ma'am, in an interview, focus on probability and statistics, yeah, continues with the ML. And most of the focus area. What is the most
See,
of focus area?
yeah, I'll tell you very frankly, you require both. Because what happens is, say there is an interviewer who is grilling you on linear regression. Now, when you are going to explain linear regression, a lot of statistics will come into play. They will tell you what is the meaning of p-value, why will you reject a null hypothesis, right? All of this becomes very important when you're looking at traditional machine learning. So a basic understanding, I wouldn't say basic, a little bit more than basic understanding of statistic is required, specifically about p-values. P-value is a question which is asked in every interview when you are starting your career as a fresher in data science. This is the favorite question of all interviewers. They will ask you what do you mean by p-value, what is type 1 error, what is type 2 error, what are the different kinds of distribution, right? What you see on the slide, these are very very typical questions that are asked. So even if you know how a linear regression works or how classification algorithms work, stats, these basic questions of stats is something that you should be able to answer very confidently, and then also link it with data science. Don't just talk about stats, you also have to make the interviewer explain how these algorithms use statistics. If you are able to do both, then you have a good chance to clear. But for that, you will need both knowledge of data science as well as statistics. At least basic knowledge is required.
Thank you so much, ma'am. Basically, I practiced the minimum 2 years of the stats.
Mm-hmm.
Maybe it's good.
Hmm. Hmm. Okay.
Ma'am, but previous interview I faced I prepare for the particular states, but they not ask anything particular statics.
Then I think you are lucky because most of these students are, while they are able to answer questions on algorithms, they struggle with statistics. And I think it is more about your own understanding than the interviews, right? Because even later on, as you progress in this field, if you have a clear understanding of statistics, you will be able to understand more complex algorithms also, because at the back end, most of these algorithms use statistics. So learn it from that perspective. Don't learn it from a perspective that will I be able to answer questions in the interview. Of course, that is required. That is the ultimate aim. We are doing this course so that we get a job, but we are also doing this course so that we understand the basics, right? So do it from that perspective. I think it should be okay. But I'm telling you because these are the questions that every interviewer asked. I'm surprised that nobody asked you questions on stats. It's quite surprising.
Yes, ma'am. This is for me particular.
Hmm. Hmm.
Okay,
But
thank you so
study
much.
it because it will help you, is all I can say. It will help you get better understanding. See, when you are doing decision tree or when you are doing random forest, right? They use these bagging and boosting approaches. Both
Yes.
bagging and boosting approaches are based on sampling. Now, if you don't know what sampling is, how it is done, what is sampling with replacement, what is sampling without replacement, you will not be able to understand how decision trees and random forest are working, right? So that is why understanding these concepts is very critical.
Yes, ma'am. Thank you so much, ma'am.
Welcome. Okay, maybe what we can do, see, I'm going to cover, these are certain topics that I had kept. If I go through all, it would be a little late. You can let me know what is something that you would like to understand. I have a section on distributions. Then I am also talking about central limit theorem. And then there's hypothesis testing and certain tests that we would be doing, and covariance and correlation. So you let me know which is a particular section that you would like me to take, and we can spend the next 10-15 minutes talking about this. Because if I cover the whole deck, it will take a little long. And given it's a Sunday, I'm sure most of you would want to complete the session at the earliest. So yeah, let me know. I'm okay to take up any.
I'll vote
And
for the hypothesis, please.
Sorry?
I'll vote for the hypothesis.
Okay, okay. Anyone else who wants to do something
ma'am,
different?
NO and chi-square.
RAM tests.
Tests, right? Okay.
NO and chi-square
Hmm.
is
Hmm. Okay. So
chi-square.
basically, okay. So let's do this. I have not covered chi-square. I have limited myself to basically the tests that are done on numerical data. Chi-square is basically done when you do a test on
Category.
categorical, but I can give you a brief explanation of what chi-square does. How do you use it in real use cases? So let's do this. Let's go to um, hypothesis testing. This basically distributions, I would strongly recommend, while there are a lot of distributions, but guys only need to focus on few of them. So when you're talking about discrete distributions, you should look at binomial, Poisson, and uniform. When you're looking at continuous distributions, you should look at normal, exponential, and again uniform. But uniform distribution is both discrete and continuous. But most of the time, the data that you will get will always be either normal or exponential, or it will be binomial or Poisson, right? So focus on these 4 and 5 distributions. That should give you a good start. These are basically just examples. Central limit theorem is also important. If you are done with hypothesis, I'll just quickly touch on central limit theorem. Again, it's a favorite of interviewers. Let's jump to hypothesis testing. Okay, so I have what I have done is I have just put these terms here, and I have included a definition for each of this term. Don't bother to read these definitions because these are all textbook language. You will end up more confused. Just listen to me. I'll try to break these terms into in a simpler manner so that you understand the gist of it, right? So first of all, in hypothesis testing, the first word is hypothesis. What do you mean by hypothesis?
Assumption.
Yeah,
Assumption.
right.
Expectations.
You're making a certain assumption, you're making a certain statement or a certain claim. Now, this assumption or claim or a statement can be made by anyone, by you, me, any research agency, any educational organization, any client. These statements are known as hypothesis. If you remember, some years back, there was this one company that manufactures Complan, right, which is an energy drink, and it said that if you have Complan every day, your average height would increase by say some X inches, right? That is a claim that the company made, right? This is a hypothesis because we still don't know whether that claim is correct or not. So such statements or assumptions or claims are known as hypothesis, right? Now, what is hypothesis testing? Now, once I have made a claim, it is not a universal truth unless I test it. So the process of testing a hypothesis is known as hypothesis testing, post which either the hypothesis will be accepted or it will be rejected. Yeah, so hypothesis testing is basically you perform certain test on the data, right? And then you conclude whether the hypothesis is correct or not based on the sample of data that you have collected. Now, once you get a certain exemption, right, you have to make two hypotheses, null hypothesis and alternative hypothesis. So basically what happens is a researcher or say the company, right? The company that is saying that if you drink Complan, your height will increase by, say, for example, 5 inches. So that is a claim that is made by the company. That is the alternative hypothesis. Usually what we want a statement to be true, we want the claim to be true, right? That becomes a part of the alternative hypothesis. The complement of alternative hypothesis is null hypothesis. So null hypothesis basically is a very lazy hypothesis, right? It will say there is no relation between drinking Complan and the heights of children. Or say, for example, again, going back to the salary data set, I have the salaries and I also have a gender. Now, I'm just looking at the salaries and I'm making a claim that the average salary of men is greater than the average salary of women. So this hypothesis, I would want to prove that this claim is correct. So this becomes my alternative hypothesis. While the null hypothesis, again being a lazy hypothesis, it will say there is no relationship between the salaries of males and females. So it will say opposite to that of alternative hypothesis. So in this case, my null hypothesis is the average salary of men is less than equal to the average salary of women. With me so far, did you understand the example of null and alternative?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay.
Yes, ma'am.
Now comes p-value. In a very, very simple language, p-value is the evidence in support of null hypothesis. If you have a larger p-value, you will go ahead and accept the null hypothesis. If you have a lower p-value, you will go and reject the null hypothesis, right? How do you decide what is a high value of p and what is a low value of p? For that, we use alpha, which is a significance level, right? If the alpha is, if I take alpha as 0.05 and the p value is less than 0.05, I will reject the null hypothesis. If it is more than 0.05, I will accept the null hypothesis. Simply putting, just remember, p-value is the evidence in support of null hypothesis. Lower p-value indicates greater evidence against the null hypothesis. When you search for p-value on Google, right, you will get a lot of statistical description of this term. It is not as complex as it sounds. When you start using p-values in linear regression, what will happen is, say for example, you're doing a linear regression problem, right, where you are predicting, say, the salaries of of individuals based on their qualification, based on their age, how many years of experience they have, and so on. So you will look at what is the you will look at each variable, and you would look at the p-value of each variable in connection with the dependent variable. When the p-value is less than 0.05, or for that matter, any level of alpha that you have selected, what you are going to conclude, this variable does not have a significant impact on the dependent variable. So a gender does not have any impact on the salary if the p-value comes to be less than 0.05. This is where in practical you use the p-value. But again, as I said, let's not go there. In the simplest form, p-value is the evidence in support of null hypothesis. All of you with me so far?
Yes, ma'am.
Yeah, ma'am. Got it.
Okay. So now let's look at how we actually do hypothesis testing, right? These are the series of steps. The first thing is you write down the hypothesis either in your mind or on a piece of paper when you are solving problems, that this is the hypothesis that is obvious from the data. Gender is playing a role on salary, right? So that is your hypothesis. Now, basically, hypothesis is defined using certain parameter. The average salary of men is greater than the average salary of women. We are talking about a certain parameter. We are talking about salary, and we are talking about average salary, right? So mostly hypothesis is about mean, but it can also include proportion and standard deviation. However, in most of the use cases, except for research, most of the use cases talk about mean as a parameter in hypothesis, right? So you describe your hypothesis, then you define the null and alternative hypothesis. So for example, when I'm saying that based on certain exploratory analysis, I've seen that my assumption or the data, what the data is telling me is that the salary of men is greater than the salary of women. So in here, my alternate hypothesis is the salary of men is greater than the salary of women. The null hypothesis, because it is a complement of alternative hypothesis, becomes the salary of women is greater than equal to the salary of men, right? For example, over here, if the claim is the average time spent by women on social media is more than men, right? This is a claim, this is a hypothesis. What will be the alternate hypothesis? We want to, the claim, you would want to prove that the claim is true, right? So that becomes your alternative hypothesis. The opposite is null hypothesis. So what it that be? It would be that the mean time spent by women on social media is less than equal to mean time spent by men on social media. Is it confusing or is it little clear?
Clear, man.
Yeah.
Clear, ma'am.
See, these are certain rules that you need to keep in mind when you create your null and alternate hypothesis. A null hypothesis cannot have a not equal to sign. Even though it is a lazy hypothesis, if my hypothesis is that the average height of students in class 4 is 4 feet, right? The null hypothesis will not say that it is not equal to 4 feet. The null hypothesis will still go ahead and say it is equal to 4 feet. Why? Because you cannot use not equal to sign in null hypothesis. Similarly, you cannot use equal to sign in alternate. So it can never be less than equal to or greater than equal to. It will always be either less than or greater than. Equal to sign only comes in null hypothesis. So null hypothesis can have an equal to sign or a greater than equal to sign or a less than equal to sign. These are certain rules that you keep in mind when you create your null and alternative hypothesis. Aligned
Okay,
so
ma'am.
far? Yeah. Okay. So now I have defined my null hypothesis. I have defined alternative hypothesis. The next thing that I will do is I will calculate the test statistics. What is test statistics? I have a sample, I have a population, right? So while I have collected, say, heights of 100 students in class 4, there will also be a population mean where it's much larger than the sample, right? So my X bar is the average height of the students in the sample that I have. Mu that you see here is the average height of the students in the entire population, right? So this statistic will be X bar minus mu divided by the standard deviation by root n. This is a formula that you, again, this will differ for every different kind of a distribution. When you're looking at a normal distribution, this will be a Z statistic. When you're looking at a sample and a normal distribution, this will be a T statistic. When you're looking at chi-square distribution, this will be a chi-square statistic. But basically, you calculate a test statistic, which is the difference between the estimated value of the parameter and the hypothesis value, right? Usually you will have your X bar, you will have the mu. Of course, standard deviation you can calculate or it would be given, and n is always the sample size, the number of observations. So you calculate your Z statistic, right? Now, once you have your Z statistic, you calculate the p-value. But before you calculate the p-value, you also have to decide what is the level of significance that I want to take. What should be the value of alpha? Alpha basically is the probability of making a type 1 error. Okay, I don't want to make it very confusing, but just simply remember, let's just look at type 1 error for today. Type 2 error, you can go back and do your homework. Type 1 error is the conditional probability of rejecting the null hypothesis when it is true. You would want to have this probability as low as possible. So what happens is when you're doing certain medical experiments, right, specifically in the medical field, you want to accept the null hypothesis, right? You don't want to reject it when it is true, because the stakes are very high in the field of medical science, right? In those experiments that are conducted in the field of medicines, right, your level of alpha is very, very low. So basically, depending on what is the context and what is the problem statement, you will decide on the value of alpha or the significance level. Using the Z statistic, you will calculate the value of P. And if the P value is less than the significance level, you will reject the null hypothesis. If it is more than the significance level, you will accept the null hypothesis. So if I am accepting or rejecting the null hypothesis, it will have an impact on what kind of variables am I going to take into my final model if I'm just talking about how it is actually used in a data science scenario. Clear? Questions, doubts? Should I repeat the entire process again?
Ma'am, I have a question that
Hmm.
Ma'am, here we are calculating Z stat by this formula, and from here we can calculate Z score as well from by the use of Z score table. But how can we calculate P score from here? As because when I go for it in Geeks for Geeks, there they have mentioned critical score. What is that critical score as well?
So this is basically, there are certain functions in the Excel and also in Python which will help you calculate your critical Z value and the P value based on the Z statistics that you get. So you just need to Google it. Nowadays, nobody refers to those values which are given at the end of the book. You can just either do it in Excel or you can do it in Python, and you will get the values of P, because P value is basically given as in very layman's term, when you plot a normal distribution curve, right? P value will be the area under the curve. Once you get your Z or Z statistic, you will get a value of P based on whether it is a two sample test or a single sample test. If it is a two sample test, then on both the sides of your curve, you will get a certain P value which you will add up. Or if it is a single sample experiment that you are doing, you will get a p-value on one side of the curve. So basically, to sum it up, you can use both Excel or you can also use Python to calculate it. The functions you can easily Google and get it. If I am not wrong, how you calculate is basically you do some it's a function called NORMSIN inverse or something in Excel. You can use that also, but it is, you can easily calculate is what is the summary.
Okay, ma'am. Thank you, ma'am.
um Okay, okay. What I would suggest is, let's first of all try to get these two steps correct. This is very simple, right? Because you already have these values. But if your null and alternate hypotheses are not correct, right, then even if you calculate the p-value, you will not be able to reject or accept the right hypothesis. So first, try to understand how do you create your null and alternate hypothesis, and then you look into these steps. These are all mathematical steps. There is no logic or understanding here. Basically, you calculate your test statistic, then you look at based on the Z statistic, you look at your p values, then you decide on any level of significance level, and then based on that you accept or reject. But the critical thing is how you define your HO and HA. This is very important. It is a little tricky also. These are very simple examples, but as you progress, the examples would not be so straightforward. So this is the key. This is all maths. This basically just formulas. Yeah, Ansh, tell me.
Ma'am, I'm still not clear what's the difference between population mean and statistical mean, and why are they not both the same thing?
So you're not clear with X bar and mu is what you're saying?
Yes, ma'am.
Okay, so see, what happens is your X bar will actually change. It will vary with what? What do you think the mean value of your sample will depend on?
Yeah. The sample will take our
It, it,
calculations.
hmm. It basically depends on your on the sample size, right? It mostly depends on, first of all, how unbiased your sample is, right? Then what is the sample size, or what is n? So your X bar will be different because you are looking at different samples, but your mu will also be different. Sorry, your mu will not change, because there we are talking about a much larger sample, or we are talking about the population in general. So what happens is, I am making a claim about the population. So I'm saying that, say, the average income of families living in Bangalore is greater than 4,200. For example, I'm making this. Then I create a random sample of 40,000 families, and I find that the disposable income for these 40,000 families is say 4,250, for example. So what happens? The X bar here is 4,250. This is the sample mean. But my mu is what? It is 4,200 because it is based on a much wider sample size. Of course, we will never have the population. It is impossible. It is time consuming. It is very expensive to get the population mean, but there will always be certain estimate of the population mean. So that's why when you do X bar minus mu, they will never be equal. They might be close, there might be a difference in it, but they will be different based on the kind of sample that you have, the sample size, the approach that you have taken to create that sample.
Oh, okay, then. Now it's clear.
Yeah, when you start looking at more examples, right, this concept of X bar and mu um, will start making more sense.
Okay, man. Thank you, man.
Yeah. Let's just quickly do this one more thing because I want to make sure that this is more clear. As I said, this is very important. Once we are done with this, we can close the session. So I want you to now tell me. Let's look at these four. Tell me what would be the null hypothesis here? Average annual salary of data scientist is different for males and females. What do you think is the null and the alternative hypothesis
Average
here?
annual
Null,
salary of data scientists is same for males and
null is both
females.
equal.
Is
Uh,
same.
Salaries of both males and females are equal, which is considered as null hypothesis. And we can
right,
consider the claim of that statement as alternative hypothesis.
right, exactly. So I will say the annual salary of male data scientist is equal to the annual salary of female data scientist. That is the null hypothesis. Alternative hypothesis is it is not equal to. Right? Good. Now we say on average, the professionals with MS in data science earns more than professionals with MS in engineering. What would be the null hypothesis? Only the null hypothesis here.
So the
Yes,
null
generally
hypothesis will be
speaking.
the professional with MS in data science and MS in engineering will earn equal.
Yeah. So the null hypothesis here will be the professionals with MS in data science is less than equal to what professionals with MS in engineering earn. Clear?
Clear, ma'am.
Yes,
Yeah.
ma'am.
Clear, ma'am.
Okay. Let's just look at the last example. I think this has now started making sense to you. The average time taken by the passport office to process the passport application is within 30 days.
The average time is
Not
greater
within
than or
30
equal
days,
to
not
30 days.
within
More
30
than
days.
30 days.
Hmm.
Greater than equal.
Yeah, so the null hypothesis, it is greater than equal to
Greater than
30
30
days.
days.
Yeah, an alternative hypothesis is it is less than 30 days. Good. So basically keep these rules in mind. This becomes simpler once you have the correct null hypothesis and alternative hypothesis. These steps are basically just simple formulas and calculating the Z score, critical values and P values. This becomes simple. The key is this. Rest, I think the others are self-explanatory or if it is just basically formulas. So yeah, I think we are it's already 6:35. Any specific questions on the topics that I have covered so far? I am okay to take or
Ma'am,
anything just on your data science journey. Yeah, tell me.
ma'am, how much stats is required for becoming data analyst?
You should be very good in descriptive statistics. Uh, that is definitely required. You will not be doing a lot of hypothesis testing. So yeah, uh, the a little difficult part you can let go. But from a data analyst point of view, you should know how to analyze individual columns. So then you should also know how to plot them, right? Because there are certain graphs that you can plot for numerical data. There's certain graphs that you can plot for categorical data. Then how do you make insights from that data, right? What is each chart giving you? What message
Yes.
it is giving you? That also becomes very important. So based on that, I think focus more on descriptive analytics, focus more on correlation. That is good enough.
Inferential statistics is not required.
It won't be required in so much depth. Inferential becomes more important when you are doing using models, right? but that is when it becomes more relevant. When you're working as a data analyst, basically you will basically be looking at the data and trying to create certain insights, which you will do. You will of course create certain hypotheses, but I have not seen a lot of people using hypothesis testing in data analytics. You would basically just look at correlation, or you would do a univariate and a bivariate data analysis and conclude your insights. But it is good to have, see, this is very basic. You should know what a normal distribution is. That is required even if you are go for a data analyst job. So you should know what different distributions are. That is also required.
Okay,
Because
ma'am.
if you
Thank you.
are looking at a data, say for example, you are analyzing the customer call service data, the number of calls that a customer care receives, right? Most of the times it follows a certain distribution known as Poisson distribution. Now, if you don't know what is Poisson distribution, then what kind of analysis can you do? You can't do much, right? You should know what is the average rate of occurrence. How does it look like? How does the value of lambda change over a period of time? Does it change? Does it not change? So distributions are important. The only thing I think you might not require too much is basically deep dive into hypothesis testing, but I think all other parts that I have covered today will be important.
Ma'am,
Yeah,
Thank you, ma'am.
thanks. Yeah, tell me.
uh, is it significant to remember all those sigma values, significance values?
No, you don't really need to remember this. So, see, based on your experiments, usually see the significance level is in 9 out of 10 experiments, unless you are in a medical field or in a field where the stake is very high. Generally, the p value is, the significance level is taken at 0.05, and you alone will not be deciding on this. This will usually be a group take. You cannot decide what kind of significance level I should take, because when you are really performing experiments, when you're actually doing it, right, it is more of a group or a team call than your own call, because the cost of uh, committing a type 1 error is very high, right? So you, of course, you will have a say in it as you start progressing, but it is mostly a team's call. And as I said, 9 out of 10 times you use alpha is 0.05, unless you are into a very specific kind of a research role.
Okay, ma'am. Okay, thank you so much.
Ma'am, I have
Ma'am,
two
I have
questions.
one dot.
Yeah, tell me.
You go ahead, please.
Okay, thank you. Ma'am, so Python provides libraries like SciPy and Stats. So do we need to have a hands-on experience, manual experience to calculate this test, hypothesis testing, or just
No, you
Python
can
libraries?
use, yeah, you can use Python libraries. That is good
So only
enough.
Python libraries is enough.
Yes, you can use Python libraries. If when you are you can use both Python and Excel. It is good to know, right? If you are just initially when you will begin your learning journey, it is good to see how things work in Excel. But slowly, when you are on the job, you will have to use Python. Know
Okay,
both,
thank you.
but at the end, you will using more of it in Python only.
Okay, Guru, you can go ahead.
Ma'am, I have two questions slightly out of scope of today's session.
Mm-hmm.
Number one, your perspective on data scientist versus AI researcher versus AI engineer. And second
Mm-hmm.
question is, as a third year computer engineer, we've
Mm-hmm.
been told to practice a lot of DSA questions because they consider that as holy grail of most of company interviews. So also your
Mm-hmm.
take on that, because that takes a significant amount of time to practice.
Mm-hmm. I think third one is very important. As a computer engineer and later on either as a data scientist or a data engineer, data structures are very important. Spend as much time as possible, because a lot of engineers, even after completing engineering, struggle with the concepts of data structures. So irrespective of whatever role you take in the future, right? And right now, I think it is a little, while you might feel that you want to go for X role or Y role, you would use data structures in most of the roles. So make that as a very strong foundation. Um, your next question on whether as a data scientist or an AI engineer, it's something that you will have to explore. Both of them are equally interesting, depends on what challenges you more, what makes you more excited. Both of them have equal opportunities. Uh, what has happened lately is that most of the companies have now stopped making models, because how much more models can you make, right? Um, you might you already have certain set of models, you try to tweak certain parameters, try to make it a little bit more accurate, but there's only a limit till which you can make it more, your accuracy can increase, right? Most of the companies are now actually looking at how are actually looking at data engineering. So it is your call, as I said, what makes you comfortable or excited about a role. But yes, data structures is something that will always be required and will always be in demand, and you will always be tested on it as a computer engineer.
It was a pleasure attending today's session, ma'am. Thank you so much.
Thank you.
Ma'am, as you said, data set is very important. So, in the field of data science, also, is it important to have a strong foundation of data structures, or
Yes.
just basic questions are enough?
No, see, I suggest you do it, because as you start solving more complex problem with and very large data sets, right? This data structures will help you. A lot of time I've seen the teams struggling with deploying the model. They're struggling with you know even basic data science approaches also, while it might not require you to do use a lot of DSA, but when you are cleaning the data and all of that, you will require those concepts. So please don't give it like uh, uh, give it importance, give it priority. This will come handy.
Okay, ma'am. Thank you. Thank you for your all these guidance.
Most welcome. Any other questions?
I'm
Madam,
send the PDF link, this slides ka link.
I am not sure if I can share this. I will check with the admin guys. If they are okay to share it, I will definitely share it. But what I understand is you guys have already been given certain notes on these topics that I have covered today. Is that true?
Ma'am, they are only articles. So, your
Hmm.
PPT is very much useful.
Okay, sure. Okay, sure. I will share it. I'm coordinating with someone called Vikas. I'm not sure if he's also the guy with whom you are coordinating. I will send this PPT to him, and he can then forward it to all of you.
And ma'am,
Ma'am, you
can we
can
have an
share in the
official
chat
group?
group.
I will have to check with Vikas first, because they would want you to refer to Geek of Geeks articles, right? If I share it, I'm not sure if there would be a conflict. Let me get these basic things in place first. I'm okay to share it, and there's no big deal in these slides. But Vikas or the organization might have certain reservations, so I don't want to share it right now. Let me have a word, and I will share it. I mean, this is no. It's not a secret, or it's not like very confidential stuff. I'm okay to share it. Let me get a go ahead from